Let's move one of these over. All right, so I'm gonna do a more difficult one than these for you guys. I'll leave the easy ones for you guys. Look at number. Let's see, what number is it on your sheet? Well, it's number 6. I just don't know which number 6. Is it the first number 6 or is it the second number 6? It's actually the second number 6. Yeah, look at the second number 6. So it's the back page of the second page.
Oh, we're doing it dead.
What? Oh, I lied. Oh, just for you. You studied? You did. Nobody studies for anything. That's how I know that.
2 plus 2.
Nobody studies for anything.
2 plus 2. 4.
Nobody studies for anything. Oh, speaking of which, you don't need calculators just yet. I don't know if you will need calculators. All right, so here's your problem. I'm gonna do it the way that we learned the other day. It's not gonna come out perfectly, but you'll see about what you could do. That'll be a good example of how you can sort of adjust if you want to do it this way. All right. Actually, it wouldn't come out very even anyway. Huh, that's a really weird one done. Oh wait, yeah, no, this one will be fine. This one actually will work perfect. All right, so remember, I told you last week, because a lot of you were getting pretty good at graphing when y is all by itself. Just picking that last number as your y-intercept, then using the number with the x as your rise and your run. So I showed you last week, if you weren't here, this is a review. I showed you how to take an equation and rearrange it so it is like that. Oh, no, I am recording. Oh, no. So again, we can rearrange this and get y all by itself. And then for some of us that are really getting good at that method of graphing, this is one that's pretty easy to solve by graphing. Otherwise, it's a little tricky to solve because of the inequality symbols. It's much easier to solve by graphing, and it's much more fun to solve by graphing if you do it the way I do. I will show you. All right, so what's the first step? Does anybody actually remember the first step to rearranging? It's only 2 steps. First step. No, first step is actually never multiplication. No, well, again, in this class, the equations you get, you're always going to add or subtract first which term. Well, which variable is specifically? Yeah, the x term. Because think about it, we want y all by itself. If we add 3y, we're just moving 3y to the other side. Because we're going to have to do the same thing to the other side. So doing something with the y first wouldn't make any sense. We want y by itself, so we're not going to touch the y. We're going to get rid of the -3 eventually, but we're not going to touch the y. So we need to get rid of the x term first. You should have this written down. I'm going to go quickly. I'm not going to rewrite it. So I need to get rid of this 4x term. A little bit. So in order to get rid of something, I do the opposite math. And I already told you it's always going to be either adding or subtracting. So in this case, the opposite is subtracting. But whatever I do on one side, I got to do to the other side. And really all I'm doing is I'm just moving it to the other side. And the way I move it is I have to get rid of it first. And that forces me to do the same exact thing on the other side. I cannot do anything with the 9 and the -4x. That's the thing you've got to remember for the rest of your life. You cannot add or subtract a term with a variable and a term without a variable. Cannot do it. And we're creating right now an equation we're going to use to graph the line. But when we divide by a negative, we still have to flip the symbol. Hopefully you can see that. That's -3y is less than -4x plus 9. So there's our first step, only 2 steps. Step 2, we're going to now get rid of that -3. And this is where we have to be a little bit careful because the one difference in solving an inequality versus solving an equation is when we divide by a negative or multiply by a negative, but we don't really ever have to work with that. So here we're dividing by -3 to get rid of it, just like we would in a normal equation. But because, and when we divide by -3, we have to divide both of these by -3. Like that. A little easier to see. I'll just do it on this side over here. We're dividing the -4 by -3 and the +9 divided by -3. Have to divide both numbers, remember that. Now we've gotten rid of the -3. That's the whole reason we did it, was to divide it out, make it go away. But because we divided by a negative, we've got to flip that sign. Just be careful. We did that before when we solved inequalities, but when we graphed it, we didn't really have to worry about it before. We do when we're doing inequalities. We do have to worry about that. So you have to understand -4 divided by -3 is a positive. Whenever you run into dividing, you have to think about what your rules are. So it's still 4/3. So I'm just going to write 4/3. And then don't forget the x. The x can't magically go away. Ooh, lost my. So the x can't magically disappear, so x is still there. And then you can divide that out, and hopefully you get a nice round integer, because that makes it easier to put on the number line. If it was a decimal or a fraction, you'd have to just take your best guess at where it goes. In this case, though, 9 divided by a -3 is -3, so we write that as subtract 3. And now we have a nice round number to start with when we graph. So graphing, again, I'll just do it. It's a review. Hopefully you know it. I'd rather you just practice anyway. -3 is our first point. Right there. Y is all by itself, so we can graph it with the y-intercept, which is the -3, and then the slope is the rise over the run. So I'm going to take the 4/3. That is my rise and my run. If one of them was negative, or if the fraction was negative, you'd make the top number negative. I would always go right first, as long as I set it up correctly. The top number will be the only number that could be negative. The bottom number should always be positive. So I go right 3, +4. I go up 4. That's where my second point is. Again, I'm graphing the first line. Don't forget, we have 2 lines to graph. I'm going to do that again. The more points we can fit on the graph, the better chance we can kind of tell where they meet. Another one, I'm going to do the same thing and flip both directions. So instead of right 3, I'm going to go left 3. Instead of up 4, I'm going to go down 4. That's a pretty straight line. If I connect all those dots, I'm going to have a pretty straight line. And an inequality, what's the next thing I need to check? Could have done it at the beginning. I should have done. What we say when we have inequalities and we graph them, there's 2 extra things we do that are different from an equation. What he said earlier. We have to check something about the line. What do we have to check for the line?
See if it's true.
Well, that's the shading part. We'll plug in 0, 0 and see if it's a true statement. But before that, it's the easiest thing you can do with graphing an inequality. You can do it before you even start doing anything to the problem. You just look at the equation for the inequality, not the equation. Specifically, I'm missing it in this inequality. Not there in this one. Oh. Line, solid, or dash. So remember to check that, because that I do mark that wrong. I do. If you just get the fact that the line is dashed and it's completely in the wrong spot and you shade in the wrong spot, I give you credit for the line being dashed. So don't ever forget this part. It's the easiest point you get. Or unfortunately, it would drop you from a 100 down to a 80 if you forgot it. So there is no line underneath that symbol. There's no or equal to part. So that means it is a dashed line. I'm just gonna, actually, I won't. That one, that's fine. So make it as close as you can to the middle of those dots. Like you want it to go right through the corners of those squares. Because wherever it meets, although that's really more for when you have equations, not inequalities, wherever the two lines meet in the past was the solution. Now, though, we're going to have a different solution. That's the trickiest part about this lesson. The main part kids get wrong. So in an inequality, there's a third step. We have to shade. One of the sides is the answer side. The reason for that is because we don't need the left side to equal the right side. That's why when the two lines cross, wherever they cross is the solution when it's an equation, not an inequality. If you don't know what I'm talking about, like if this symbol here would have just been an equal sign, if both of the symbols would have just been an equal sign. That's what I mean by wherever they cross is the solution. In this case, though, there's an infinite number of solutions because I just need this left side to be less than the right side. There's a whole bunch of combinations of numbers that can make the left side less. That's why we have to shade. So I need to do what to test and see which side I shade. Last step. Yeah, what do we do? I just like to pick it. What do we do? Plug something in. Plug in. Big guess. Easy to remember now. 0. We are going to plug in this point right here. We're going to plug in x equals 0 and y equals 0. The only reason I picked that point is just because it makes math easier normally. I could pick any point I want. I could pick any point over here. Well, actually, I take that back. You cannot pick a point on the line. That's the only thing you can't do because we've already drawn the line. A point on the line has already been created. We did that when we graphed. So we got to pick something off the line to see if it's a solution. 0, 0 just is normally the easiest math. As a matter of fact, it's so easy, I don't even really have to plug it in and show it. Because if I plug in 0 here, this just goes to 0 because that's 4 times 0. If I plug in 0 here, this just goes to 0. So that's why we choose here. So the left side is 0. Right side still 9. So I ask myself, I'll write it over here. That's what I would get if I plugged in 0 for x, 0 for y. Again, I'm testing this spot. That's why I'm saying x is 0, y is 0, because that's what they are at that spot right there. Is that a true statement? Is 0 less than 9? Yeah, absolutely. If it's a true statement, then that's the side we shade. So I'm going to shade this side. Now, let me ask you this. See if anybody's actually paying attention and awake. And this was one of your quiz questions on one of the quizzes, and a bunch of you missed it. I just circling back. So weird. Oh, there we go. I don't know how it erased when it should be. What is it? Delayed. So is the point, let's see, what can we go with? 0, -3. Is 0, -3 a solution? Why not? It's on the line, so is it a solution? Why not? I thought the line was all the possible answer. We're doing that. So here's what you have to remember. Points on when it's an inequality. Points on the line are sometimes solutions. It has to do with whether or not this symbol has the equal to. If the line is solid, then they are solutions. If the line is dashed, they are not solutions. That's what the dash means. It means the points on the line are not solutions. If it's solid, then they are solutions because there would be a little or equal to, meaning all the points that make the left side equal the right side are solutions. All right, so now, as Logan was saying, we got to do another equation. So I'm going to do the same thing here. Actually, you guys try to move that around. So you're trying, I mean, if you know how to graph it like that, you can just graph it like that. You don't have to move it around. That's a pretty easy one to actually graph. You just want to come up with two ordered pairs that make the left side equal the right side. Gonna lose a tooth? I got pliers. I can pull it anymore. I can pull it if you need it. Cheaper than going to the dentist. So however, if you want to move it around, move it around. If you just want to try to graph it like that, you could create a table. That's the other way to graph if you don't remember. X, Y. Why is my board so delayed? I'm not gonna worry about that right now. It didn't even write it there. Oh, no? Huh. So weird. Oh, maybe it's didn't select a color, maybe? Huh. Oh, killing me. Seriously? I wonder if maybe if I just use my. Say it again. You good? Yeah. I hate it when I do this in recording. Ah, son of a gun. What if it erases? Let's see if it erases. It does erase. So weird. Does my board do weird stuff? Well, no, because the eraser works. If the eraser works, the pen should work. Although the eraser didn't work like it's supposed to work, but it did work. Let's try to. If we can. Huh. It's really weird. Oh, maybe it's just part of it. Interesting. It did this one time before when it wasn't more like. Oh, see, I can't start on this side and write, but I can write on it if I start on the other side. That is crazy. Crazy. Huh. So what I was going to show you, if you want to graph this, you can also, I can't right there. I'm going to have to erase this, but I'll just show it to you. If you want to graph this, the other way is you can do a table like X and Y. I could plug in 0 for X and then solve for Y. Then plug in 0 for Y, solve for X. That would actually be a pretty easy one to do that way. Comes out to be two pretty easy numbers to solve for. I'm going to still do it the other way where we do it, change it around and do rise and run. All right. Oh, I did not mean to do that. All right, so I'm going to change it around right now if you're still working on it. Are you graphing it or changing it around? All right. I'm going to change it around. So to change it around, what's the first step? We want to get y by itself. Always first step. Always the same first step. Well, we add or subtract. It'll be the opposite. So in this case, it is subtract x. It's always the x term, which means we got to subtract x over here. So we get 3y is greater than negative x plus 6. Now we divide by 3, divide by 3. Remember, there's a 1 in front of the x. So how to fix this? Oh, actually, here, this will be faster. I'll fix it in a second. There. So there's a 1. I wonder if that fixed my writing. Nope. So there's a 1 in front of the x. So when I rewrite this, oh, I divided by a positive, so I don't need to flip the sign. So this is negative 1 over 3 times x plus, oh, I forgot to divide the 6 by 3. Fix that if you didn't catch it when I did it. You got to divide both things by 3. Do not forget that. So 6 divided by 3 is 2. That's my equation. I can now use the y-intercept and the rise and the run. I guess I'll go ahead and graph it. I'll graph it. I can zoom in a little. There. All right, so I have a positive 2 for my y-intercept. So I just put a point on positive 2. My run is positive 3. That's the bottom number, positive 3, which, like I said, should always be going to the right first. Negative 1 for the rise means I go which direction? Up or down? Down. That's where the lines are going to meet because I landed right on top of that dot. But I'm still going to keep going 3 to the right, 1 down to draw a straighter line. I'm going to reverse it. I'm going to go 3 to the left and now 1 up. To reverse both directions, plus the points just need to be in a straight line. If you go down again, you can see they won't be in a straight line. So again, that's where our other one would be. Now we will draw a straight line in from there. And that's pretty good there. All right, so there's my second line. Now I have to do this. Oh, is it a dashed or a solid line? I made it dash already. So answer that. But yeah, the symbol is just greater than. There's no or equal to part, so it has to be a dashed line. Now I can go ahead and say, okay, well, which side do I shade? Because I do have to shade for your final answer. So I do have to shade. Now here's where it gets really confusing. You already have one line and one shaded section. Kids get super confused about where they shade now, even if they do the math correctly. So same math, I'm going to plug in 0, 0. So again, I'm testing this point right here, 0, 0. As long as it's not on the line, that's the point that's easiest to test. If I plug it in, I get 0 plus 0 is greater than 6. Your left side is always 0 when you test it, even in the other type of equation. Is, again, 0 plus 0 is 0. Is 0 greater than 6? No, 0 is not greater than 6. Not even close. So that means this time 0, 0 is not a solution. When you shade this second line, ignore you got to write this down. I'm telling you, some people are going to forget it. Ignore everything else on the graph. Just look at the line that you just created, the second line you created. Ignore all the other shading, ignore the other line. You are shading one side of this line. Actually, here, we'll make that line. I don't want to make it. I guess we can make it blue. So we are shading one side of the blue line. This dashed line doesn't matter. Kids stop because of that line all the time. We're not shading that line. We're doing one equation at a time, which means we're shading one line at a time. The first line's easy because you don't have anything else on there. It's the second line that confuses kids. So when I go to shade this, oh, I didn't do that. When I go to shade this, I'm going to shade this section over here because that's above that line. This didn't work, so nothing down here is going to get shaded. This side should work because one side has to be the solution side. So I'm going to shade up here, and this is why it's my favorite lesson. Because when I cross over into the part I already shaded, it makes green. So it's a science lesson also. Yellow plus blue makes green. If you have the right yellow and blue ones. If they actually mix. So that tells me something about this system of equations in line. And there will be one problem where I just give you something already shaded. So there's kind of 4 quadrants of this. You'll notice one shaded in yellow, one shaded in blue, one shaded with green, one shaded with white. Anybody tell me anything about those quadrants? Yes. What do you think, Kayla? Anything you can tell me about that? Keep in mind, we said equations, which inequalities are the same thing. Inequalities are just rules. So this is just a rule. The left side has to be less than 9. Here, the rule is the left side has to be greater than 6. I normally open it to word problems, but since nobody's here, so or an example word problem and how this applies on the inside. So this parents ever say that to you? Not mad. Very fine. I don't know if I ever actually use it. Okay. So, here's what it means. Just write this down. There are 4 quadrants. Each quadrant means something. Now, if you're shading with one color, it's sometimes a little tricky to see what the 4 quadrants are because you're just gonna have gray everywhere. So somehow you need to maybe shade the first line a lighter color, second line lighter, and then what would be the green section. So what is the green section? Why did it turn green? I shaded that with both colors, right? So I shaded the green section. We'll start with this section. This section was shaded twice when I did both lines. I shaded it when I did the first line. I also shaded it when I did the second line. That's your solution section. Because it works for both inequalities. That's why we shaded it twice. We shaded this twice because it worked for this problem. We shaded it for this one because it worked for this problem. So it's kind of like when we get a system of equations and we said the answer is where they cross. The answer was where they cross because that point worked for both equations. It made both equations work, made them true. The reason why this is the solution is it works for both inequalities. It makes this side less than that side. It makes this side greater than that side. So again, the solution section of the graph is the section you shaded twice. The simple version. Now, what do you think is true about this section then? White didn't get shaded at all. Doesn't work for either equation. You pick a point in this section, which we're going to do. Let's try to pick an easy one. So 4, 0, right? That'll make our math pretty easy. It's got a 0 in it. If I plug in 4, 0 into either inequality, it shouldn't work because it was never shaded. If it worked, it would have been shaded at least once. So 4 here is 16. 16 subtract 0 is not less than 9. So didn't work for that one. So 4 here plus 0 is not greater than 6. 4 is not greater than 6. Didn't work for either one. That's what the section that was never shaded means. No point in that section will work for either equation or inequality. Same equation. So now we're down to the yellow and blue. What do you think yellow and blue mean? The idea now I've given you the image. That's exactly right. The yellow works for the equation we did first. Any point in the yellow will work for that one, but not for that one. The blue, which we did second, so we did this one second. The section that is just blue will work for this one, but will not work for that. And we'll test that out. So we'll take 7, 0. Should work for this one. 7 plus 0 is greater than 6. Yep, 7 is greater than 6. Should not work for this one. 7 times that is 28. Subtract 0. Yeah, 28 is definitely not less than. So again, that's what the four sections mean. There will be some kind of a question where you don't graph anything. You just explain something like what I just told you. Section shaded twice is the solution section, or yeah, I guess section. Yeah. And then the section not shaded at all means none of those points work for either equation. And then the yellow works for the first equation we did. The only blue works for the second equation. All right, so go ahead, practice a little bit today. I'm not going to kill you since you guys are in here. But again, this quiz will be your last new grade, and it can count as a replacement for the quiz. If you want to look it up, you can see what you got on it. Actually, what was the name of it? I'll look it up. Here, I'm going to go ahead and stop the recording so I can look that up.